I'm going to start with just a refresher of Filecoin storage, and then we will get to Filecoin virtual machine. And this is just to introduce maybe some of the audience members who are a little new to Filecoin about how it works. So there's a number of technologies involved. The first is content addressing. The second is something called interplanetary linked data. We'll mention IPFS momentarily. And then there's Filecoin that sits on top of all of this. But to start with the content addressing, I actually like to talk about the internet first. So who here is familiar with their IP addresses? Everyone should raise their hand. Yeah. So your IP address is actually a geographic location. And so to actually retrieve data on the internet, it's actually quite inefficient, and there's a range of other issues. For example, links are kind of broken. If you think of a link like a website like puppies.com/beagle.jpg, you would expect there to be a photo of a dog there, but actually it could very easily be a cat. And thousands of these websites could host the same photo. So our answer to this is something called content addressing, taking its inspiration from something like the ISBN system for books. In the ISBN system, you have a unique identifier for every book that's ever been published, and that identifier actually tells you something about the book, its genre, etc., etc. And so when data or any file is uploaded to Filecoin or IPFS, it actually goes through a hashing algorithm that computes a unique identifier that we call a content address, a CID. What's interesting about these CIDs is if you upload the same file, you get the same exact CID. If you make even the slightest change to that file and run it through the hashing algorithm again, you actually have a change in the content address that is produced. So one of the interesting use cases for this is from our social impact partners at Starling Lab out of Stanford University. And what they do is they go around to places like Bosnia and Ukraine, and they take photographic evidence of war crimes happening in these places. And then they have this process where they have some type of cryptography going on that shows evidence of the time and place that they took the photo, and then they immediately upload it to Filecoin. And the reason for that is those photos are then content addressed, and they know in perpetuity that no one has tampered with that evidence. And so when they go and they submit a dossier to the International Criminal Court, as they did actually 2 months ago with a case for Ukraine, the court can be assured that the data is legitimate and no one has tampered with it. Yeah, okay. Now, you might say, okay, Robert, that's interesting. You just have a bunch of photos that are, or files that are uploaded. They have this unique identifier, and they're just floating around the net, or whatever you want to call it. What then? How do you organize this data? So you might say, okay, Robert, that's very interesting. You have all these files all over the place, and they're uniquely identified. How then can we understand how these files are organized? And just as you might have a folder of pictures on your computer that have some cats and some fish subfolders where you have maybe all your photos of cats and all your photos of fish, we do something similar on Filecoin, except we use some graph theory. So who here did computer science? Who's familiar with graph theory? Okay, cool. So in computer science, let's say you're an undergrad, you'll take your second semester freshman year, Mathematical Foundations of Computer Science, and you'll spend a whole 2 weeks on graph theory. And then you will be very miserable doing the assignments and then trying to figure the questions out on the exams. But in graph theory, you have two different types of elements. The first is a node, So in this case, a node can represent anything. In this case, it represents a folder or a file. And then you have edges, which connect nodes together and represent those relationships between the nodes. In the case of Filecoin, the graph that represents the data added to Filecoin is something we call a directed acyclic graph. Why do we call this a directed acyclic graph? Well, it's directed because our edges have direction. When you visualize this, it's literally an arrow between nodes, but that shows you the relationship between two nodes. For example, we have cat's node and an edge directed towards this tabby photo. That tells us that this tabby photo is in the folder called cats. And we also say it's acyclic. Why is it acyclic? Well, in graph theory, if you can go from one node to another and then back up to the other node, that is called a cyclic graph. You have a cycle. You could go around and around and around as much as you want. Graphs need to be acyclic to show this relationship because think about it. Let's say you have the cats folder that's in the pics folder, and then you have an edge also drawn from cats to pics. You're also saying that the pics folder is in the cats folder, and that would make absolutely no sense. So this is a directed acyclic graph, and it actually gives us some very compelling features. For example, these DAGs are recursive, so you could traverse them over and over again with the software that you write. You don't need to recover or retrieve the whole DAG to get specific information in the DAG. By the way, every edge is also a CID. So everything is represented by a content address in the DAG, and you get this very interesting situation because this is a data structure that represents all of the data on Filecoin. You can more efficiently organize the representation of this data. This is one of my favorite examples, and it's actually a word I can't really pronounce. Deduplication. Okay, I can pronounce it. But you could see this, let's just say it's a file, is in both this folder and this folder. Instead of having the file represented twice in two separate folders, you just have the two folders pointing to the same representation of the file. So this makes it much more efficient to go through that data. It's important for me to note IPFS at this time. So IPFS is compliant to everything we just talked about. Content addressing, interplanetary link data. This is a hypermedia protocol that lets you share data, but we're going to talk a little bit later about the difference between IPFS and Filecoin. This brings me to Filecoin, by the way. So in Filecoin, and usually, by the way, this is taken from my other talk, so usually there's some context about proof of work and proof of stake, but we'll just skip all that and talk about exactly what is a Filecoin storage deal. So let's see if I have a laser. Oh, that's okay. That's very interesting. Can you guys see the laser? Wow. Okay. Very interesting. We may have just damaged the little LEDs that are in there. Yeah. So okay, cool. I'll come on this side. All right. So the anatomy of a Filecoin storage deal. So first of all, what is the point of Filecoin? All of the data on Filecoin is compliant to this content addressed interplanetary linked data situation, but Filecoin actually as a blockchain is the storage and retrieval marketplace for that data. So the idea here is you have people we call clients who have data they want to store, meeting storage providers, many of whom you've met yesterday here in Korea, but meeting storage providers at the marketplace to come to an agreement about how to store, come to an agreement as to the price and the duration for which they would want to store data with that data center. So the way this works and why the blockchain is so important is the blockchain gives us the cryptographic guarantees that the data is actually stored where and when the storage providers are promising. So how does a Filecoin storage deal work? First of all, a client someone with data that they want to store. That made no sense grammatically. A client who has data, they want to store this data with a storage provider. They come to Filecoin and they say, hey, I have this much data, I want to store it for this length of time, I want to pay this much Filecoin. That is called a storage deal, and they will propose this. First of all, when they propose this, their data gets converted into the Filecoin data type that's compliant to everything we just talked about, and they will propose this. The storage providers will then look at the deal and say, hey, that's very interesting to me financially. Maybe one of them is willing to take that deal. So in order to signal that they are taking the deal, they do something called proof of replication. This is a type of proof of stake that more or less allows them to show that, hey, we have made a copy of your data on our data center, and once this deal and the proof of replication is published to the blockchain, that is the signal of the start of an actual arrangement between the client and the storage provider. Step 3 is, well, here's a question you might ask. Okay, Robert, why would a client pay all their Filecoin up front for a certain time duration deal? How do they have a guarantee that they're actually going to keep the data there for that long? And the answer is they don't pay people up front. The client doesn't pay the storage provider up front. The client will actually pay over time, and they will only pay when they are given what is called a proof of space-time by the storage provider. So this proof of space-time is another cryptographic proof that the storage provider presents to the client saying, hey, I have your data in the literal memory space in my data center at this period of time. You can continue to pay me Filecoin. If the storage provider fails to provide this proof of space-time, they suffer from something called slashing. So this was mentioned by Juan yesterday, but in his FIL Plus discussion as to how we can ensure notaries are well behaved. But slashing on Filecoin for storage providers is if they fail to show a proof of space-time, they actually have Filecoin deducted from their wallet. So you get heavily penalized if you do not act as good stewards for the data that the client stores. And then finally, step 4, you'll notice I mentioned that these deals are time limited. We'll come back to that idea in a moment. But towards the end of the deal, a client either needs to decide, hey, do we renew this deal with this storage provider, or do we find a new storage provider and store this data somewhere else? Maybe it's cheaper, maybe they have more trust with that storage provider, et cetera, et cetera. So that is the anatomy of a Filecoin storage deal. Now, okay, we'll skip that. What is going on here? Oh, you know what? This is a video, but I think in the interest of time, we will skip it. Okay. So now we have a number of interesting things that we've built on top of Filecoin. What I'm going to tell you about is Filecoin Virtual Machine, but there are other very interesting stuff going on. For example, FIL Plus, which are notaries that ensure that the data being added to Filecoin is useful. Now, useful means a lot of different things to a lot of people, but you can, Juan is going to come back today and talk about FIL Plus. I encourage you to go to that. I think it'll be maybe a group session up here. We also have what was called Bacalao, is now called LilyPad. This is compute over data. So this is actual compute jobs being done on the data being stored on Filecoin. So you could imagine doing AI type of stuff, AI ML jobs with that. FVM is on-chain programmability for Filecoin. So you could think about it also as compute, but we're doing compute on the metadata of the Filecoin storage deal. So for example, and this is actually probably one of the biggest things to clarify, Bacalao, now called LilyPad, is compute on the data that's actually stored in the data centers. Filecoin Virtual Machine, it's still, there's computing going on, but we're dealing with programmability of the data or the metadata of the storage deals. So for example, the time the deal happened, or the who the storage providers are, et cetera, et cetera. We'll get to that a little later again. All right, Filecoin master plan. Step 1, build the world's largest decentralized storage network. We basically accomplished this. I believe that the latest figure is the amount of data stored on Filecoin is equal to 2% of the global cloud storage data, which is really, really compelling. Step 2, onboard and safeguard humanity's most important data. This is an ongoing process, and we have a lot of very interesting institutional clients, such as Internet Archive, New York City government, Harvard libraries, that have stored their archives on Filecoin. And step 3, bring compute to the data to enable web scale apps. So that is what Filecoin Virtual Machine helps accomplish. So the FVM delivers on-chain programmability to the Filecoin network. And this is what the FVM stack more or less looks like. And what's very interesting about this diagram is that FVM is actually kind of in this bottom layer that is the Filecoin node. Why do we say that? Well, first of all, if you're a storage provider, any storage providers here right now? Okay. Oh, okay, perfect. So you're probably running Lotus. Yes. So if you're running Lotus, you're actually also running FVM. So FVM is built right into Lotus. So usually, I guess we would call this something like, FVM would usually be a layer 1, but my colleague Zach Ayesh from FVM DevRel actually likes to call FVM layer 0.5 because it's actually being run with the Filecoin node. So if you're already running Lotus, you're already running FVM. I'll go back for a minute. Something that's really interesting as well is you can have native WASM actors. Actors are what we call smart contracts on FVM. And these can be user-defined, which we really are looking forward to what the developer community ends up building with respect to user-defined WASM actors. Why is that? We think they'll be much more efficient in terms of actually they'll be much more efficient because they're actually going to be native to FVM. Right now, we are running what's effectively a virtualized machine on top of FVM, and it's an Ethereum virtual machine. So basically, people are building on Filecoin Ethereum virtual machine. And the reason for this is so much of the tooling built for Ethereum is what the developers are used to. And so this makes it really easy for them to develop on FVM. For example, who here is familiar with MetaMask? Okay, so right out of the box, MetaMask works with FVM. We also have Filecoin Solidity libraries, which is now in the Filecoin project GitHub, that allows our developers to write in Solidity these smart contracts. But you can write smart contracts on FVM in any language that compiles to WebAssembly, WASM. Okay, let me just see if there's anything else I need to mention on this slide. Oh, I see. I should probably mention that there's a lot of interesting projects coming up that we think are really compelling. One of the things Juan mentioned yesterday, interplanetary consensus subnets. We think that this will bring scalability to Filecoin, and FVM enables these types of IPC subnets. And then renewal as a service. So I'll talk about this again later, but Filecoin deals are time limited. You might have a service provider that monitors the blockchain. Maybe as a client, you'd subscribe to the service provider, but they'll monitor the blockchain to see when these deals end up expiring and will act to renew those deals automatically for you. Okay, this is the layering. Something I do want to mention, there's a lot of talk, oftentimes, whenever you talk about Filecoin, you talk about IPFS. They're actually two separate networks. And what Filecoin delivers is something of, I don't want to say guaranteed, but some more assurances that your data will be there over time. That comes from the storage marketplace concept. You're actually paying to make sure that your data stays there. That does not exist on IPFS. So you'll see this is what an IPFS, this is what the IPFS stack kind of looks like. You could run your own nodes. You could run nodes with the community. Maybe you will pay for a pinning service like Pinata, but long story short, there's no guarantee your data will stay there. But with Filecoin, because the blockchain access that marketplace, you have some more of a assurance that your deal will be there in perpetuity. And then FVM will more or less enable a number of different use cases on top of the Filecoin blockchain because you can do custom logic around the storage deal creation and retrieval. And FVM actually sits right in the blockchain layer. We will have like kind of these layer 2 apps as people build on FVM like Collective Deal. Okay, cool. And I already talked about this because it's EVM compatible. It's compatible with a lot of tools that people are used to. Hardhat comes to mind, Foundry. That's an example of Solidity, which we will get to. Okay, now you might say, Robert, there are so many EVM chains. Why would we build on Filecoin? I think it's a common question from developers, and the answer is Filecoin is the only blockchain that actually gives you storage with their applications. There's a picture of a storage container unit. Okay. This is from Phil Fox. This is a block explorer. This is the deal list. Another misconception. So the first misconception we discussed was, where does FVM sit in the stack? Another misconception I'd like to just bring about is, what is a storage deal actually? Most people, like, if I were to just say storage deal, they think, oh, the actual data that is stored with these storage providers. This is not true. When we say storage deal, what we're actually talking about is all of the metadata that describes that deal. We're not talking about the actual data being stored. And so you can see here, you have all of this metadata. This shows all the recent deals. I just pulled this picture today. I don't know if some of the storage providers recognize their own identifier here, but that'd be really cool if they did. Maybe not. Or maybe we have a client in the room that recognizes their deal. I don't know. But you could see we have a number of different information. You have the deal ID, the time it was created, the client identifier, the provider identifier, the piece size, whether or not it's a verified deal. So piece size, did I get into this or not? Okay. Something that was discussed yesterday by Juan is that the fundamental unit of data on Filecoin is 32 gigabytes or 64 gigabytes. And this is actually, how do I say this politically correct? This is a constraint for developers. I think that's a good way to put it, because developers oftentimes want to do deals that are much smaller. But for a storage providers, they want to make sure the sector of 32 gigabytes or 64 gigabytes is filled, because if a developer only wants to store, let's say, 3 gigabytes, it's going to fill a sector, and the developer is only going to pay for the 3 gigabytes, but then the storage provider has the extra 29 gigabytes that's just sitting there, that they can't fill. So we'll talk about aggregation soon, and how developers can actually aggregate their deals with other developer deals, or other deals generally, to fill a sector before it's actually added or accepted by a storage provider. And then verified deal, this is the FIL Plus situation. 97% of all deals are now FIL Plus verified. These are notaries that will make sure the data is useful. The reason for that is the storage provider gets a 10x on the miner's reward. But I think there will be many changes after some community discussion about what needs to happen on FIL+. Okay, so the reason I bring this up is FVM deals with this kind of data, the metadata of these storage deals, and it allows developers to bring programmability to this type of information. For example, you might write a smart contract that renews a deal with a specific client. Or, you might write a smart contract that identifies a certain client and their deal and renews it with a certain provider that you set. That might be an example. Okay, let's see what we got. Okay, we have FileCoin Solidity Library. Again, this allows developers to build in Solidity. There's smart contracts, and then, okay, Zach Ayesh is going to give us a bit of a demo using the Solidity library, but let's see if there's sound.
We have this concept of storage deals, which has existed since the beginning of FileCoin, and we have this Solidity EVM runtime. How do we connect the two? Well, we work together with a great team of developers at a company called Zondax to create FileCoin.Soul and the FileCoin Solidity libraries. And these act as an interface between the traditional FileCoin APIs and getting those storage deals into your smart contracts and the Solidity world, right? And since I have GitHub open, I'm already open to the page here. And we can come and click on contracts here under the Zondax FileCoin Solidity. And this is currently in the progress of being moved into the FileCoin project GitHub. But you'll see a bunch of Solidity files here. These represent what we call inbuilt actors, or you can think of them like Ethereum precompiles if used in the Ethereum world. This is logic that's pre-built in from the old APIs in FileCoin, and these are the interfaces in Solidity world, right? So I click on Market API. There's a bunch of methods here that we can call in Solidity to get and set a bunch of different information on deals. I actually have some code in Remix running right now. Remix is a very popular IDE for getting started in development in Solidity world. And this is a simple getter contract that just imports that market API, you'll see that at the top, and calls a bunch of getter methods and stores them in these state variables over here in the top, right? And this is just to show, like, hey, this is how you can quickly get deal information in. Any deal that exists on the FileCoin blockchain can be retrieved this way. You just provide a deal ID in for each of these methods, and you can write logic around deals, right?
Okay, cool. By the way, this computer is on fire right now.
Data.
Okay, let's...
So we have this concept of storage deals, which...
Okay. We're going to watch this over and over again. This is... let's see. Here we go. Yeah, but it... here we go. Okay, sweet. But now let's just... Yeah, okay, perfect. Okay. I don't know if I'm missing a slide between that video and here, but I dare not press back. We will watch the video again. So we'll just go with this. Okay, now, you have all your tools that you need to build on FVM, Hardhat, Foundry, MetaMask, etc. You have the Solidity library, so you could write in Solidity these WASM compiled smart contracts. Now you might say, okay, Robert, how do I know whether or not I need to build with FVM? And on FileCoin, there's basically 3 paths towards doing storage that I'm going to explain to you right now. So the first is this non-programmatic storage. So this is just data of any size. You just need to upload it to FileCoin, no problem. You just do simple storage with a storage on-ramp, and maybe later you'll build some type of app or tool on top of that data that references that data in some way. No problem. Just standard FileCoin storage. But let's say you need programmatic storage. some type of business logic on top of your storage deals. Well, there's another question you need to consider. How big is the data that is going to be involved with each one of these storage deals? If it's greater than 4 gigabytes, that's great. Generally speaking, you could just do direct deal making with the deal making starter kit. This is something available on our FVM hackathon cheat sheet. But more or less, this will use FVM to do your storage deal, and it's big enough to where you don't need to aggregate it before you build your DApp or your tool. However, if your data, generally speaking, is less than 4 gigabytes, you might want to consider using an aggregator. One example is Lighthouse. Another example is, well, what was called Filecoin Data Tools. It might have been retired now, but I'll have to check if this is updated. But deal aggregation effectively allows you to include your deal with a bunch of other deals into one bigger deal. And so, generally speaking, this should be more interesting to storage providers to pick up your deal. Okay. And the use cases, by the way, are many. I'll talk a little. Okay. I might be missing slides. But you could think about a number of different use cases. One of my favorites is perpetual storage. So you can write FVM smart contracts. Let's say, okay, so here's the example. You do a storage deal as a client, and you want that data to be with that storage provider or any storage provider for, let's just say, forever. Whatever forever is. You might, instead of every 6 months at the end of a storage deal, instead of every 6 months going and manually renewing the deal, you might write a smart contract that you endow with some Filecoin. And let's say that endowment is invested somewhere, just hypothetically speaking. Let's say that investment, let's just say it returns, I don't know, just hypothetically an average of 8% per year. Well, you can write the smart contract logic to then say, okay, if this endowment made more money last year than the storage deal will cost next year, renew the deal. If not, find a new storage provider that will let us do this for cheaper. And so technically, you can get that software to renew the deal in perpetuity forever because you have this endowment and the FVM smart contract will handle the renewal for you and you never have to do it manually. Another great example is DataDAO, which we'll talk about in a moment. You can have a situation where multiple people are involved in managing, let's say, a data set. And let's say they're maybe scientific researchers and they've created this data set together. Maybe there's 5 researchers in the lab. They create a data set together. They want to sell it to third parties. Well, they can write a smart contract that will lock that data. If a third party pays the smart contract, let's say 10 Filecoin, they get to see the data, and then that 10 Filecoin can be dispersed between those researchers. FVM, you can also do data access control. So this would be, for example, you have a family photo album stored on Filecoin. You only want to allow your family members to actually see that data. Well, you can encrypt the data and then set the Filecoin addresses for whom the private key would actually unlock that data. And you could do all of the very interesting use cases that are already known to the crypto world that you could just do with smart contracts. On-chain voting is a very interesting one. Yeah, okay, cool. If you ever take a class with me at a university, you will do a voting use case. So, okay, cool. This is an example of a data DAO. We call it Biscuit DAO because this is the Filecoin Foundation mascot. It's a corgi named Biscuit. Come to another FIL event, you will get a corgi, like a little plush animal. Sorry, we couldn't ship it here. I know, I'm sorry.
Las Vegas?
The Las Vegas one will be limited edition, themed like Elvis. So come to Vegas, get a corgi that looks like Elvis. Yeah, it's actually really cool. I don't think we haven't seen the Istanbul one yet. We'll check with Gary. I can almost guarantee there will be one. What was that? What was that?
It should be cut in Istanbul, probably.
Yeah. Oh, yeah. I believe.
RTFS pack.
Yeah.
Yeah.
Any plan in Istanbul from Falcon Foundation?
Yeah, we're hosting a face there.
You should be.
What was that? Well, I'm not going to Vegas, so Jenks will have to bring us back some corgis, you know. So, yeah. One of the good ones was Lisbon last year. We had space. We had corgis in spacesuits. Anyway, cool. Okay. So, example of a data DAO. Let's say you have a bunch of corgi owners. They want to manage data related to their corgis because they want to learn more about the health of their corgis. Well, they may have ZK verified contributors to actually access a smart contract. And if they're verified, they can upload data about their corgi. Let's say it's their health data. And with that data, the DAO can then vote on what to do with that information. For example, training an AI model about their corgi behavior, or give access to the data, give access of the data, give access about the data. I don't know. I don't even know the grammar for this, but give their veterinarian access to the data. Yes, there we go. Okay. They might decide to vote for that. And maybe they can build other cool things with FVM. For example, the Treasury can handle persistent storage. You could do renewal, repair, and replication, which maybe we'll get to at the end if we have time. Or you might send some of this Treasury money to a DEX or some type of cross-chain token bridge to have other services that might support the DAO. And the result is maybe happier, healthier corgis. Who knows? Okay. This is a QR code to our Data DAO kit. We are currently in the middle of the Open Data Hackathon. So this is a remote hackathon that runs from now to September 20th. So that's the deadline to submit. I mean, technically you could start building 3 days before the deadline. But anyway, this will get you started with the bare minimum needed for a data DAO. So take a screenshot, I don't know, open the link. It's a very good QR code. If it's working. I hope it's working. Okay, good. Cool.
43,000 prize pool.
Yes, there is a lot of money up for grabs in this open data hack. So, it won't be for nothing, I promise. Well, if you win. Okay, cool. But I'm judging. Nepotism, I don't know. I met you in Seoul. I like you guys. So, okay. Okay, LilyPad. So how does FVM and LilyPad interact? First of all, what is LilyPad? I mentioned it earlier, Bacalao LilyPad. This is an off-chain compute of the data stored on Filecoin. And this is compute over the actual data stored on Filecoin. Where FVM comes into play is you can initiate these jobs from FVM. So for whatever reason, you might have, I don't know, what might an example be? Well, you might have an FVM smart contract that monitors when new data is added to a certain, I don't know, storage provider. And the FVM might say, hey, retrain this AI app, more or less, with this new data that's added. Water Lily is a very interesting app that's been built on top of Filecoin. It's live. It uses FVM. It's generating AI art. And they use FVM also to ensure that some of that revenue actually goes back to the creators on which this AI art is inspired by. Okay, these are some of the really interesting tools that are being, or are live or being built for FVM. You have access controls, network analytics, oracles, containers, all things that will help you understand what's happening on FVM so you can better build on FVM. Okay. Okay, good, we have time. All right, this is what the, let's say, diagram is for aggregation. And really, it's kind of self-explanatory. You have a bunch of different clients, maybe they're developers, that want to have their deals aggregated into one larger deal. Well, an aggregator will put that together. There are two options. One is to use what we used to call a decentralized aggregator, but I think we changed it for the purpose of the docs, where it's software that will do this, or you can use a centralized aggregator like Lighthouse, which is much more common. But you can imagine what's happening is those deals are being compiled and then proposed to the Filecoin network as one storage deal. But what's interesting about this is we have something called PODSI, so proof of data. James, is it proof of data segment or sector inclusion? I think it's sector. Okay. Anyway, proof of data sector inclusion. Okay, Timo, cut this part from the recording. I should know that. Yes. Okay, good, good. But this is cryptographic evidence that your data has actually been included in the bucket of segment. Oh, it was segment. Okay. I thought it was segment, but then I was thinking sector is the file. Segment inclusion, yes, exactly. Okay, good. So proof of data segment inclusion, this is cryptographic evidence that your data is actually included in the aggregated deal. This is a diagram of renewal as a service. Long story short, we kind of want developers to build this, but you could imagine you have some renewal as a service node monitoring the blockchain, and then basically determining based on when that deal will expire, whether or not something needs to happen, for example, a renewal job or a replication job. And we suspect clients will subscribe to these services to make their life easier about storing deals. Okay. Deal flow on Filecoin. Now, this kind of gets into a little more our difference between aggregators and direct deals. So, first of all, data size. If you're below 4 gigabytes, you're using an aggregator. If you're above 4 gigabytes, usually direct deal making will work. Your retrievability, actually, if you're using an aggregator, you can actually retrieve that data from the aggregator even before it hits the Filecoin blockchain. With the 4 gigabyte direct deal making, you need to wait for it to hit this Filecoin blockchain. The flexibility, unfortunately, the deal parameters for aggregators is kind of limited by what the aggregator can handle. But with direct deal making, you can actually set your own deal parameters. And with respect to what technology you could use, Filecoin data tools, we used to call it Estuary. Again, we'll clarify whether or not that's been retired. But with direct deal making, we have a client contract for you. You can actually find it on the FVM hackathon cheat sheet.
Robert, you have 15 minutes left, and do you have time for Q&A?
Yeah. Okay, I'll wrap up in maybe 3 minutes, and then I'll take questions. Cool. So what does the deal flow look like? Well, clients will put fund in escrow with the storage market actor on chain. So this is deal flow using FVM to do Filecoin storage. So step one, a client puts funds in escrow with the storage market actor on chain, actor being a smart contract. The client will upload the CAR file. Again, the CAR file is the data type, the file type for data that's stored on Filecoin to a web server. So these CAR files are all CID and IPLD compliant. We talked about that at the beginning. The client sends a storage deal proposal to Boost. Boost is the software that the storage providers run to pick up deals. Right? You guys run Boost? Yeah, perfect. Boost will check that the client has enough funds in escrow to pay for storing the file. Boost will accept the storage deal proposal. It then downloads the car file from the web server, publishes the deal on chain, and the client could check that the deal was successfully published on chain. This is another aggregation redundant slide, but typically aggregation was happening off-chain all the time, but now a lot of it has moved on-chain. Okay, Matt Hamilton has some great demos that, in the interest of time, we're going to skip, but I will send the slides out and you can watch yourself. Okay. Oh, okay. Sorry, Matt. Okay, and then finally, as we discussed, replication, renewal, and repair as a service. We think that clients will want some type of RAS to make sure that their deals are healthy, let's say, and are renewed or replicated as needed. And we think some service providers will be able to fill this niche by building this. Okay. I'm going to skip that too. And that. And that also. Okay. This is a QR code. Again, this is all your FVM resources. So I believe the hackathon cheat sheets should be on there, but also a bunch of other amazing links. If you want to learn more about FVM, I would encourage you to scan that QR code and get all the links on there. Especially if you're coming to build at a hackathon, this will be very, very helpful. Okay. Amazing. All right, this is the great team at FVM who have really accomplished a lot. FVM launched in March. And if you ever see any of them at a hackathon or at a FIL event, make sure you say hello. Sarah runs the FVM DevRel team, so you'll see her and the rest of the team being Matt, Zach, and Longfei at the hackathons, being there ready to help you build on FVM. Okay. Yes. Okay. Cool. All right. Happy to take questions, but that's the talk. Thank you. Cool.
So FVM is not applicable for non-FIL plus deal.
Oh no, yeah.
It does.
Yeah.
Yes.
Yeah. Any deal.
Any deal.
Yeah. You might write some interesting FVM smart contract that discriminates between a FIL plus or a standard deal and does some certain thing based on whether or not it is FIL plus or not. So that's something you could do with FVM as an example. So, yeah. Cool. It just so happens most of these deals are FIL plus deals. So, you know. Cool. Any other questions? Yes, James.
Do you have any idea on WASM implementation?
Yes. Soon. Yeah, I'll have to check for you and get back to you. But yeah, we think native WASM actors will be very compelling. User-created native WASM actors are going to be very compelling. And the reason for that is you'll be able to do your smart contracts directly on FVM rather than doing it inside the virtualized Ethereum layer. This might be more efficient for execution. So we're very excited for that.
You need to explain what is WASM.
Oh yes, WASM WebAssembly. So if your language compiles to WebAssembly, you can write smart contracts in that language. So I believe the Java family of languages compile to WebAssembly. I believe the C family of languages compile. Most languages do, yeah. So you can write your smart contracts in whatever your preferred language is. Yeah.
Is there any medium article or GitHub source for I can quickly start with FVM?
Yeah.
Any kind of functionality like perpetual storage or,
Yeah.
or DeFi. And collective is also open source, right? You open, then people can check.
They're the only open source.
They are only open source.
Fully open source. DeFi protocol.
So I want to write a quick, simple function of perpetual storage.
Yeah. Well, not sure about perpetual storage, but this is the.
Any kind of categories.
What just happened?
NFT.
This is the Data DAO starter kit. So this will get you building a Data DAO on FVM. But if you go to the hackathon cheat sheet, we have links to get you started with aggregators and direct deal making as well. So what we call the client contract is available on the FVM cheat sheet, which is available from the other QR link. So you could immediately do that direct deal making contract immediately. Yes. Which should be this QR code. Should be there. Should be there. Yeah. Cool.
You can probably write the smart contract using ChatGPT.
Yeah. So interesting thing about this.
What is familiarity of ChatGPT or FV?
Yes. So 2 comments, by the way. There's an entire repository of smart contracts that you can just take and use as standard. I'm forgetting, maybe Jenks, you know what this is?
There is a repository of all the popular use cases
Yes.
of FVM.
Yes.
They have sample solidity files for you.
Yeah. Do you remember what that's called?
FVM event in a box has links to all of them.
Perfect. Cool.
Yeah, so if you search FVM event in a box,
Yeah.
this is Robert's curation of a lot of resources. You will find links to, for example, Data DAO examples, and there you can fork or whatever, copy, paste all these, or teach ChatGPT to write it.
Yeah.
And then you can deploy your own Data DAO.
So you probably have to use the ChatGPT 4.0, right? Instead of
No, 3.5, anything will work, but what we need to do is ChatGPT will not natively understand Filecoin ecosystem and our tooling. So it's garbage in, garbage out, so you need to feed it with good information first. So you might need to have a good conversation with ChatGPT first and teach ChatGPT about what Filecoin is about, whatever Robert just said, and then you can then show maybe some examples of solidity code that our engineers have written, and ask ChatGPT to replicate with all those knowledge in his head, ask it to generate contracts. So it will be more reliable. And then what you need to also do to use it in real life is A, testing for the user experience, but B, very importantly, you need to get it audited. So yeah, so for example, Data DAO, if anyone can hack it, then they have access to valuable data, right? So yeah, that's something that we haven't provided yet. That is audited sample solidity contracts for people to use. Thankfully, because it is EVM compatible, so there were a lot of there's a lot of example projects already tested, audited in the Ethereum ecosystem. You can just copy paste and move it to FVM. It should be secure enough.
Something I would just say that I think is very important that Jenks brought up is about testing and auditing. I found when writing software with ChatGPT's help, it can get you like 80% of the way there and give you a lot of really good syntax. But then it's your responsibility kind of to be the software engineer, the expert on, actually getting it over the finish line to be a working product. So I'd say it helps reduce time in figuring out syntax and maybe some interesting, I don't know, how you would structure your code. But it will still take that last 20% for you to get it to where it needs to be to publish. And that's just generally doing software with ChatGPT. I think that's generally true. Even if you're just writing like complicated Excel formulas, I find that, for example, there's one situation where you would have to, one situation I ran into was actually asking ChatGPT 2 different things and combining those things because when I asked them together, it couldn't figure it out. So yeah, it still takes some level of human intervention for sure. So, cool. Any other questions? Sweet. Well, no one likes anyone that goes over time, so maybe I will give some 7 minutes back to you. But thank you so much for having me, and it's been a real pleasure. Please come to the Open Data.